Hello, today we're going to be looking at organic reactions. And what do I need to know about organic reactions? What exactly am I looking for in each one of these? Well, the first one that we have is combustion. And if you read the notes that I posted on Google Slides, we're looking at slide 12. Combustion is the process of burning a fuel with oxygen, creating two products. Those two products are the same all the time. If you take a look here and here, you'll see I have CO2 and water. Here and here, CO2 and water. Here and here, CO2 and water. CO2 and water. CO2 and water. CO2 and water. So really, I have to be able to identify the reaction. And if you take a look, each one of these reactions on the left-hand side has oxygen. So really, there's not much to it. If you can remember that combustion, obviously you need oxygen for combustion to occur. Combustion is a nice way of saying burning. And the two byproducts of burning are CO2 and water. What do I need to know about saponification? The reason why I wrote the first four letters in green is because if you unscramble those letters, you get soap. And saponification makes soap. That's all you need to know. What two components do you need to make soap? You need to use animal fat and a base. With fermentation, you might have a type of problem in which they give you this. They'll give you a sugar. They'll put an arrow, and they'll write above that arrow zymase. Zymase is the catalyst or enzyme that is used in order to convert sugar into alcohol. Now, when you make alcohol, you should recognize what alcohol is. It looks like this: two C's, H, 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 and NOH. This OH can be anywhere. And as you also know, inside of like the alcoholic beverage beer, the head of a beer is comprised mainly of CO2. So please do not confuse this with a combustion reaction, because similar to combustion, CO2 is a product. But as you can see, the other product right here, this is an alcohol. This and this, there is no alcohol on a combustion reaction. So those are the main differences between these. So please keep that in mind when you're looking at these. All right, next one that we have here, polymerization. All you have to know is that this type of reaction exists, and all you have to know is the difference between a natural polymer and an artificial polymer as listed in the notes. The next one that we have is called dehydration synthesis, and to kind of show the operation and mechanics of a dehydration synthesis of the making of an ether. Let's see if we can get this to stop going crazy. Nope, it can't. To make an ether. So they call this etherification. Etherification basically takes two primary alcohols. What primary means is you have an OH on the end of the chain. That's all it means. So I'm going to take a 2-carbon chain with an OH. I'm going to take a 1-carbon chain with an OH. All right, I'm focusing my eyes predominantly on that. You're going to notice that what we're going to have is this is going to fall off, this is going to fall off, and if you take a look at what that is right there, that's going to give us HOH, aka water. The other product is the merging of these two chains, which I'm going to highlight in a different color. I'm going to take this entire chain that is here, and I'm going to link it to this right here. Now watch carefully, because this can be confusing for some. I recopy CCO like that. Okay, that's the same thing that I drew right here, no different. I'm going to take this piece right here and just attach it on. Now you might be saying, where did the HO go? Where did the H go? If you take a look, these are the components that are right here. Okay, we got the HOH. That is the water. So in a sense, snip, snip, goodbye, snip, snip, goodbye. And that gets rid of all that, creating our products that we wind up with. This is an ether. Now, how do you name an ether? Ethers are named using the left side, then the right side, and filling in the blanks with the appropriate name. All right? So to fill in the blanks on this, we have blankel, ether. What you do is you simply fill in what you have on each side. So this right here that I see in this circle is an ethyl. On the right side of that, you'll notice that this is a methyl. So I'm looking at, this is my ethyl, this is my methyl, and because of this functional group that's sitting right there that I find on table R, I'm going to identify this as an ether, as blankel ether. And that's how esterification works. Now I'm going to try to keep this on here so that you can see that esterification and esterification are easily confused because first off, the words look very similar. Ether, ester, right? They both look so similar, it's so easy to mix them up. But in an esterification, you're making an ester. So you have to really pay close attention to what's going on here. So in the notes, what I did was I took a 1-carbon acid, okay, that looks like this, all right, and I'm going to add that to a 2-carbon alcohol. This also is a primary alcohol. Again, this is a dehydration synthesis. So what's going to happen is that H is going to fall off of the acid, and the OH is going to fall off the alcohol. Again, we are going to make water, HOH. All right, so if you watch carefully, I'm going to get rid of that H on the acid. If you watch carefully, and remember, the hand is quicker than the eye. No, it's not. Just watch carefully. That is what I'm going to connect together. And that's all that's to this. You simply take repeat what you just had on the left-hand side, the pieces. There's the acid piece. And here on the right-hand side is the alcohol piece. If you notice how they named an ester on your reference table, you'll notice that this chain breaking O is the decider. What you're going to do pretty much is you name the right side first. So right there comes first in your naming pattern. So what you're going to do is you're going to fill in the blank, and then you're going to fill in the blank. All right. So filling in the blanks is as follows. If I look at my right side first, that is an ethyl. All right. If I look at what I have right here on this side, I'm going to use a different color so people don't get confused on this. This is a meth. So all I did was look at the 2 chains, eth and meth, and it popped them in the example that they gave me on table R. That's all I have to do, is realize that that chain breaking O right here is the decider. Esters are named from the right side to the left side. So that's how they name them. All right? Right side, left side. If you look at the example, you'll see what I'm talking about. Because on the example on table R, they gave me methyl propanoate. Now, if I know what meth means you have 1 carbon. Prop means I have 3 carbons. If you realize that chain breaking O embedded in there on the reference table example for ester, to the right of that is a 1 carbon. That's where the methyl is coming from. To the left of that is 3 carbons. You'll notice one of those 3 carbons is underneath the double bonded O. Remember, the O that I'm talking about is the chain breaking O that doesn't have any sticks coming out of it. It basically, if you read left to right, you see CH3, CH2, CO, CH3. And that is what I'm talking about. Reading that left to right, the chain breaking O is embedded in that line. So that is your decider on how to name that. And that's what esters are all about. Esters are sweet-smelling extracts that we find in our kitchen. For instance, rum extract, that is what is a predominant vanilla extract, and many other extracts. Sweet-smelling extracts and perfumes generally are what we get esters from. Going on to the last two reactions that we have here, we're going to now take a look at a reaction called substitution. Substitution only happens with alkanes. I'm going to take a very simple alkane here. In this case, I like to put the hydrogens down so that you can see what exactly is being substituted. All right. What they generally will have is they will generally have a halogen, okay, as a diatomic. All right. And down here, we're going to have two products. All right. What's going to happen is one of the chlorines is going to jump on the chain. So you can pick any hydrogen you want. I'm just going to pick the hydrogen that's closest. I'm going to pick that hydrogen right there and say, hydrogen, you are about to get a substitution. All right. So here we are looking at the chain that's going on right here. I'm going to pretty much recopy everything up to that point. And surprise, surprise, right here, I now have the chlorine. The chlorine has substituted the hydrogen. Only one of them will be substituted. And the remaining thing that we have left is we have the H that was right from here, and we have one of these Cl's in the Cl2 giving me that. That's a substitution. It can only happen with alkanes. It can only happen in formulas that have like CnH2n plus 2. So can that happen with C25H50? The answer is no, because it has to fit this pattern right here. That would have to be 52 in order for that to occur with that particular compound. That's how I use a general formula right here to figure out if I have an alkane. The last problem that we're going to take a look at is an addition. Now, additions will happen with alkenes. So I got to have at least a double bond. All right. So you'll notice there's 4 sticks out of every single carbon. All right. And here we are. There's our alkene. If you have the chlorine happening with this, you're going to notice we will only have one product. What's going to happen is this is going to be the focus. What's going to happen is that double bond is going to break open, kind of like a little drawbridge. And what we're going to wind up with is when that bond breaks open, this is what will result. You'll wind up with this, and now you're going to have two open sticks right here. So this is new. This that I've illustrated in pink is actually when that double bond cracks open. When that cracks open, you can get the chlorines to jump on the chain and add on. So like for instance, if you were thinking about building an addition onto your house, all right, if we talk about an addition onto my home, this would be like my home, and this would be the addition, all right? Now, people wouldn't say, I own 2 homes after they built an addition on. All they're going to say is, I own 1. 1 home means you have 1 product. And that's the reason why there's nothing else left. Everything jumps on the bus. And that hopefully has summarized all the reactions for you today. Hope that was helpful.